Okay, we're going to do question 7 from our matrices review. Question 7, part I, says given that matrix A is 13, 6, 7, 4, it wants us to find our inverse. So our first step to find our inverse is going to be to find our determinant. So we need the determinant of A. And in order to find the determinant of A, we're going to have to take our leading diagonal and multiply them, So we're going to have to do 13 times 4. So 13 times 2 is going to be our 26. If we multiply that by 2, it's going to give us 52. So we have 52 minus our other diagonals multiplied, 7 times 6. 7 times 6 is 42. So when we subtract 52 minus 42, our determinant is going to be the number 10. So that's our first step. Our next step is to multiply 1 over our determinant, which is the number 10, by our flippy matrix, our adjugate here. So we're going to have to take our 13 and 4 and switch their positions, 4 and 13. Then we take our other diagonals and switch their signs, so -6 and -7. Now our last step to find our inverse is just going to be to actually multiply out these elements inside this matrix by this scalar. So we have 4 over 10, -6 over 10, -7 over 10, and 13 over 10. And we can simplify this if we want to. We have 2 over 5, -3 over 5, -7 over 10 can't reduce, and 13 over 10 can't reduce. So this would be our simplified form of our inverse. That's it for part I. Let's take a look at part 2, part II. It's asking us to solve these simultaneous equations. So part 2 is asking us to solve our simultaneous equations. 13x plus 6y is 41. 7x plus 4y is 24. So if we set these up as matrices instead of simultaneous equations, we will end up with our first matrix just existing from the coefficients in front of our equations on the left. We have our x's lined up and our y's lined up. So I can turn this into the matrix 13, 6, 7, and 4. And that's being multiplied by the matrix x, y. And we can see that that works if we check here 13 times x plus 6 times y, that's our first term. And 7 times x plus 4 times y, that's our second term. And if we multiply these, they should be equal to the matrix 41, 24. Now, we can name these matrices if we want to and see what would happen here. So if this is matrix A, x, and b, I know that ax equals b. So if I want to get x by itself, I have to pre-multiply both sides here by the inverse of a. So x will be the inverse of a times b. Now, I already found the inverse of a in part 1, so all I have to do to find x is to take that inverse matrix, 2 fifths, -3 fifths, -7 tenths, 13 tenths, and I have to multiply it by matrix b, 41, 24. All right, I'm going to multiply these together up here. Oh, no, I'll just do it down here. We'll scooch our paper. Sorry. Oh, we're sliding. Apologies. Here we go. Now you can see again. Okay. Awesome. So let's go ahead and multiply these matrices together. So we're going to have 2 fifths times 41. 41 times 2 is 82 fifths. And we're going to have to add 24 times -3 fifths. So minus 24 times 3 is 72 fifths. So that's our first term. So we went like this. Now we're out of space here. We have no more columns. We move on to row 2 with the same thing. So we have to do 41 times -7. So we can do 4 times 7 is 28. So 40 times 7 is 280. And then we have 1 times 7. So this is 287. And it's going to be negative 287 tenths. And we're going to have to add 24 times 13 over 10. So 24 times 10 is 240. 24 times 3 is 72. So 240 plus 72 is 312 tenths, and these are going to be added. I think that's right. Let's check our math. So our matrix X is going to be equal to whatever this is simplified. Let's take a look. Some pretty gross numbers, right? So our first element up here is 82 minus 72 over 5. And I have the same denominator, so I can just subtract them. That's 10 over 5, which is just 2, which is awesome. Now I have to figure out what 312 minus 287 is. This is a little bit of awkward math. So if you'd like to, which I would actually very much like to, I'm going to just do this math off to the side. 312 minus 287. If you can do it in your head, more power to you. I'm going to go ahead and borrow from the 1. That's going to become a 0. This is a 12. That's going to be a 5. Borrow from the tree. That becomes 10. That's a 2. Hey, look at that. This is just 25. And it's going to be over 10. So 25 over 10, which can reduce by 5. So my final answer here, X, which is that matrix XY, is going to be 2 over each one of these divided by 10. So this is 5 halves. So I know separating it out by matrix, or sorry, by element, X equals 2 and Y equals 5 over 2. There we go. That's it for question 7. We'll pick up with question 8 in the next video.